I think, yeah, we are live. So 3, 2, 1.
It's like we're all giving each other a clap to begin the broadcast, which looks a bit weird.
Yeah, but this is like people coming onto the show. We need to give some encouragement or something.
Congratulations.
I think we should hold as one of those cue cards, like applause, like something like that.
It's like one of those presidential candidates. That's the time when you're meant to cheer.
So, welcome to Defn, episode number 49. And I think we are almost going to be 2 years old next month. This is a pretty long time. So, this episode is what Ray said, the crucial episode, Cruxial episode.
I don't know. You can't pronounce it. You can't say. You're going to read it. Yeah.
Exactly.
God.
So we have two gentlemen from Juxt. So Jon and Jeremy, you want to introduce yourself and then tell us a bit about what you do, and then slowly we'll move on to Crux.
Yeah, so I'm Jon. I'm the managing director at Juxt. So my life involves less coding, sadly, as the days go on. But my job is essentially to just it's a bit like attending a garden where there's lots of interesting flowers that come out, but then some weeds, and you have to go in, and you can't kill all the weeds, but you do what you do for an hour that day, push them back, and just manage things really. So that's what I do. I really do still love the tech enclosure, and it's a cliche, like it's kind of an embarrassing cliche, I think, when people say, it's like I'm post-technical, I really love to code, as though it's like they're condescending, as though like they're trying to sort of stay at one with the techies. And I felt that a bit uncomfortable, and I've resisted that cliche. But there's some truth to it. Like when you sort of just do your day-to-day, lots of phone calls and speaking to people, it's lots of activity in the brain. But when you can code, it's like that sense of self disappears a bit. And you go in like a meditative zone, and it really is quite coding. And I find it a necessary part of the job. Just it's the cliche, it's what everyone says, but it does to a certain extent keep me sane.
So you still fiddle with a little bit of Clojure then, Jon?
Yeah. Like right now, I'm sort of doing some jobs on Crux. It's good fun, really. Like it's just I want to try and help out the team, so I'll pick some of the niggly issues, just trying to trim the issue board. But yeah, still like to get into Emacs, still like to solve problems. I quite like Crux because Håkan Rayberg, who is the tech lead of Crux, he's quite a disciplinarian. He's quite sort of strict, and I quite like it's a bit like Cider, with Bozidar. I quite like that sort of authoritarian figure on an open source project, and I quite like being that person that submits an issue and is it good enough yet? Like, what do you think? And they say no. It's like there's not enough tests, not enough comments, and I quite like just working towards someone else's spec and standard. So I quite like that sort of dynamic in Crux. So it's a good place for me to be coding.
Excellent, cool, yeah. So Jeremy, what about you?
Yeah, great question. So I'm relatively new to the Juxt world. I joined in January, and really my role is all about Crux. So I guess the term is offering manager, but you can think of me as a product manager. So because Crux is a very new thing, you can think of my job as sort of really in Jon's garden, watering one solitary plant, making sure none of the predators get it, and then figuring out how we're going to take it to market, and who is going to want to use it. So I came into the Crux project reasonably late in its life, I guess. Jon and Håkan and Malcolm have been thinking about this for a long time. So I've had to get up to speed with, I guess, what Crux does, what value it brings, and figure out how it fits into the wider picture, and how, I guess, all the use cases and systems people are going to be building in the future. What part can Crux play in that? So my role is very much about making sure that as we keep investing in Crux and building it out, that we're aligning it to some real world use cases, and as we get people using it, that we're listening to the feedback and incorporating it into the roadmap. So yeah, I'm not necessarily like the engineering lead. So that's definitely Håkan's role. But I'd like to think I'm bringing a level of business focus and visibility over what else is happening outside of Crux, and making sure that we have a sort of a solid direction and strategy. So that's my role. It's been very intense.
You've got a bit of closure chops as well.
So
product manager, which is like, very businessy, etc. But you're hiding a little bit there, aren't you? Come on, there's a little bit of closure there too.
There is a little bit. So I've been I've been programming on and off, I guess, for a long time. But it wasn't really until maybe 8 years ago I got sort of quite serious about programming. Spent a while playing around with Node.js. When I realized actually that wasn't cutting it, I switched to Clojure, and this is just as a bit of a hobby, really. But I'm very interested in knowledge management, data management, and Clojure ticks a lot of boxes for me. And so I've spent a lot of time looking at how Clojure works, and I've been building various demos and prototypes and things. But it wasn't until I discovered DataScript that I found sort of a very natural place to start working and sort of finding my niche. So I'm sort of very keen on data log and the DataScript implementation and that sort of philosophy. I'd say I'm nowhere near as adept at Clojure as most people at Juxt. Like I'm very much in at the deep end, working around Malcolm and Jon and everyone else. But I hope to get my Emacs configuration in order for this game.
Yeah, well, VJ can tell you how to make Emacs look like Vim, so that could be a bit of homework for you.
But this seems like a fantastic episode. I mean, we started with Emacs already, so this is like the best episode ever. After 48 episodes, we have like a majority of Emacs users on there, or to be Emacs users.
I'm really thinking about converting to Emacs now.
Oh, yeah. What do you not use Emacs, Ray?
I don't use Emacs now.
Presumably Vim is your.
I don't use Vim. I do use VI sometimes. On
when he said converting, he meant upgrading to Emacs.
He hasn't said what he's using yet. I'm waiting for the sort of big reveal.
I use Notepad, of course. Because who wants text highlighting? That's for losers, But,
yeah.
No, everybody else in our company, by the way, including like the big guys, we all use cursive. So
do you? Right.
We haven't got any Emacs actually at the moment.
Right.
How do you think he curses a lot? That's the reason he uses cursive and then he keeps cursing a lot. That's
the thing of beauty. It's a real joy. Yeah. So it's good.
That's what I heard. Anyway, so let's get to the meat of this episode. So Jon, you live open sourced it during Clojure North, Crux. So what is Crux? So there is something on the website. We'll get into deeper different things. What is the elevator pitch?
Elevator pitch on Crux is a bi-temporal document store with graph query.
It's
Nice.
like the definition of a monoid.
Yeah, exactly.
Can we end the podcast now?
I need a T-shirt like that. That's what you should do, actually, Jeremy. Part of your product management is have like one of these, like, what is a monad type T-shirts.
Yeah, that'd be good. We did have some pretty nice T-shirts at Clojure North. Sad Jon's not repping it right now.
I was actually, as in the Clojure world, we look for the definitions or something for everything. So I know the colloquial usage of Crux. I'm not a native English speaker, obviously. But then when I looked into the Merriam-Webster dictionary, it says a puzzling or difficult problem. That is the definition of Crux. But if I saw Oxford Dictionary, it says the decisive or most important point at issue. So
I think Oxford is right there.
yeah, because it came from, I don't know, Queen's English. So I thought it is probably that one. But there is 1.1 on Oxford Dictionary that says, again, a particular point of difficulty. So that's a very interesting name. So
yeah, but it comes from Jesus being crucified and
like the cross
things like this. And so,
it's quite deep. I mean, if you want the honest answer of why we chose it, is because it had to be 4 characters. And we were walking around Bristol and looking at things like, oh, there's wood. Okay, there's door, there's leaf, there's ding. And we're thinking, what's a meaningful sort of hardened word? And after like his 5th cocktail, Malcolm pronounced, it shall be called Crux. We thought that was very good.
Well, I think if me and Ray are working, then it should be fuck, something like that. We'll come up with some other bullshit like that. Oh, shit.
I like cock. But don't put that
I'm pretty sure it's trademarked. Or they might be easier to find cock DB than Crux DB.
That's true. Anyway.
You've got cockroach DB, but
almost there.
I like to shorten it to cock DB for sure. Anyway, let's not get too rude. Crux. Crux.
Yes. So you said it's
the crux of the matter.
You said
it's a bitemporal document store that provides graph query. So let's break that down. Please do. So you're a developer, right? You chuck it some Eden documents, right? It stores them for you. Job done. That's the doc store part. Then also there's a bit of Crux that sees these documents coming in and it indexes the attributes within those documents so you can do data log graph query against those documents. Right. And then you can join documents, like you can do a data log. That's the graph document part. The bitemporal bit it's really quite simple. Like it's a problem that you didn't know that you had in most cases, right? So let's say you got a temporal database, and really let's just assume that what that means is that you can query for any point in time against the database, right? So I want to query what did the charts look like in the UK at 1997, for instance, on a particular day. That's what a temporal database can give you. The issue with some temporal databases is that if there's only one axis of time, which is transaction time, then the database is sort of recording facts at the time the database sees those facts, right? But the world that we often work in is quite messy. So you often want to enrich the past. Like maybe we're sitting now in 2019, but we're learning some stuff about the charts in 1997. Right, we might have got it wrong. Perhaps there's another chart that we want to add. So we want to add facts into the past, but you can't really do that if the only time axis that you've got is transaction time, because you can't insert into the past because the only time you've got is transaction time when the database sees a fact coming in. So when you just got the single time axis, the time is always increasing. You can't insert into the past. You maybe can if you take on some complexity, you take on a hit, you do some extra work, you do some modeling, perhaps you do some sharding. Like there's always ways around. You should build an index on top of the database, right? There's things that you can do. You can split up your data accordingly, but it's non-trivial. What bitemporality gives you is that it maintains that transaction time, that immutable transaction time that's always increasing. So you have that. Your database doesn't change. It accretes facts. That's what we want. But then it adds this valid time notion on. So you can add a fact and the transaction time of that fact is increasing. It's always going in the future. But the valid time of that fact can be in the past. So we have transaction time and we've got valid time. All valid time is saying is when this fact was true. That's it, right? So it's
according to the user rather than according to the database in that sense.
Exactly. It's according to the user. It's according to you as the programmer. So in a way, bitemporality, there's 2 fundamental time axes at work. Like one is a transaction time that the database works with at that inherent sort of level of the database. But then you've got valid time, which is more about the users, the programmers, and it's giving you more control of time, right? So you can say, look, I want to insert a fact into my database, and this fact was true in 1997. And then when people want to do as of queries or historical queries, they can use valid time. So they can show me what the world looked like in 1997. And that can then take account of these facts that have come in later, because the valid time is when it was when the user wanted it to be.
Is valid time like a kind of, does it default to the normal time? Does it default to the database time and you can kind of override it? Or is it, how do you do that?
Yeah, like I'm sure that Jeremy can correct me on the precise syntax, and I'll hand it over to him in a sec. But yeah, you can submit a transaction into Crux and not give it a time, right? And then it just like the valid time and transaction time is like now. Or you can be specific and say, okay, this is the valid time that I want. The transaction time will still be derived by Crux, but the valid time is something essentially you can override.
Yeah. Okay.
Yeah.
Makes sense.
Yeah. So bitemporality does have like a lot of ambiguity in the word. Like if you look at what other things do that claim to be bitemporal, there's a broad range of definitions. So some databases, and Jon wrote about this in his blog post, you have a valid from and valid to field, whereas Crux essentially has just basically just a valid from with like an implicit valid to. So the valid time you insert document sort of means that document is valid until the next document is inserted in the temporal order. So there's some nuance in that model, but essentially it's it also they're dualisms. So you can use that to model the higher level concepts.
The other thing that I always think about, like, because I used to be a database guy back in the day, was that the problem with the database back in the day was that you had to kind of like add timestamps into your data. And then if you wanted to reconstruct the database as of a particular time, it was kind of on your own dime, basically. You had to design it up front so that all of the tables all had the same type of date fields in them.
Yeah.
And that's what everyone did. And then you basically had to make a query that said, okay, give me the information across all these different tables, as of that time. So how does that differ? I mean, I do know the answer, but fuck it, I'll just ask you anyway. How does that differ for your database? So do you have to put all these timestamps all over the place, or how do you get to a particular snapshot in time? Yeah.
So the answer is that all the timestamps are sort of implicitly recorded unless you specify a valid time along with your transaction. So the transaction time and the valid times that are recorded will be according to the current time of the Crux node that's making that insertion. Now there are some implications around what happens to the Crux node. Clocks are slightly different and all that kind of thing, but we can talk about that later. But at the lowest level, you're not having to manually manage these timestamps, but you're not precluded from then inserting additional timestamps inside of the documents themselves. So you can model sort of domain times in addition to valid times.
So
as well.
Is the valid time kind of an mandatory thing in Crux document?
So the valid time isn't inside the document, although I think there are advantages to putting it inside the document because then you're able to query against it. But but by default, valid time is just simply a way of making corrections to this temporal view.
Okay. So how do you? Sorry, Jon, you were saying something, or?
No, shoot. No, I'll sort of button afterwards.
So how does the schema look like? Because I'm trying to understand this from the trying to contrast it with something like MongoDB or a NoSQL database like Cassandra or something, or I'm trying to understand it from the relation model. So how do you contrast them with these two types of databases?
So I'm not an expert on the MongoDB query language, but my understanding is that MongoDB does give you some reasonably sophisticated ways of navigating around, but it's still not generic, sort of MongoDB won't automatically index all the fields, whereas Crux takes that view that actually if you just index everything, then you can do these graph queries very efficiently. But there is no schema, so the indexes aren't being built to correspond with the schema that you design up front. It just happens that when you insert a document, all the fields are automatically processed, and this only happens at the first level of fields. Like if you had nested fields within the document, they wouldn't get indexed. So again, there's some nuance there, but essentially the fact that it's schema free, it's schemaless, means that the indexing is very simple, and that you can design these graph queries to do schema on read.
Oh, okay. So I don't need to specify that. For example, so I can. I'm just thinking out loud. Like if I'm getting started, then I put up Crux, and then I can put any Eden document into the database. That's it. So it's the experience is similar to MongoDB, for example. There I just throw in some JSON/BSON document, and then I'm done. And then it automatically thinks, okay, these are the fields I have. And the next document can have a different schema, so to speak, different fields in the same collection. So from the storage wise, what is the concept you have? Like, is there every document is independent, or can I have like collection of documents like other document stores?
So currently everything is in a single sort of monolithic collection, that there is no separate abstraction which we've defined as collection. Okay. But because of the way it's indexed, again, you can pretty efficiently model your own sort of collection semantics. And of course, you could have multiple Crux databases as well if you did want to have different collections.
So it's like the ultimate spreadsheet where you just basically just put data on this huge grid, and you just pick out the information, like you say, schema on read. You just decide which view you want to have when you read the thing, rather than when you write it.
Yeah, I think that's a nice way of thinking about it. Certainly, spreadsheets are quite novel in terms of making programming simpler for some value of programming, and I'd like to think that Crux makes databases simpler. Again, for some value of database, but Crux certainly makes it easy to have that on ramp from, okay, I'm just going to store these documents. I don't really know what's in them. That's the MongoDB use case. But then as you want to build tighter and tighter constraints around how you're querying and doing further indexing on those documents, you have that flexibility without having to bolt on a whole different query engine.
So just a quick question on that then, because I know you guys are very seated in like the practical world of, finance and business and stuff like that. And, again, back in the day, people were always very concerned about, the correctness of data, especially for like governance perspective, to make sure that they conform to regulations and stuff like this. So what's the kind of motivation for having this totally freeform model? Or is it a completely separate sort of, what's driven that? What's driven that kind of like, is there a business use case there that you're kind of trying to answer, I suppose just the question.
So I have an answer, which is that Håkan, who built this, primarily he built the simplest possible thing he could in the shortest amount of time, and that's why it is the way it is. But he's done it with the view that everything else is something you can decide later or design later. So it's not necessarily the case that Crux does everything you could possibly want to do in terms of access controls and validation on rights and that sort of thing, and even things like transaction functions. But the view is that all of these things can be achieved on top of what the core already provides. The core is simple for maintainability reasons.
Yeah, I think it's not necessarily the simplest thing that we could get done in the shortest time. It's more that the design of Crux is layered. So we want the core to be as fundamental as possible. So we don't want to have stuff in the core that you can add as like a decorating layer. So that's the direction of travel, and Crux has this layered sort of design. So things like aggregating data, extending the temporal capability, those are things that will come in as middleware or decorators, or maybe even because Crux is open, it exposes all these various protocols, and you can swap the various bits and pieces. It's unbundled in that design. So it's entirely possible that someone will create a library out there that configures Crux in a certain way that adds their own code. Then we'll take that over time into our repository. And we want Crux. It's a bit like the way I think about the design is a bit like the sun, like in the center of the sun. It's like, the photons take the longest to get out from there or in there, right? And that's a bit like the core of Crux. It's going to take the longest to evolve, because what we absolutely don't want to do at this stage is, the scheme is a classic example. Like if we add that into the core now, then there'll be some people out there that would be like, well, why do that? Like, I don't necessarily need the schema on write, I prefer it on read. So if we keep it out of the core and then we add it to the higher level where it's optional, then everybody sort of has their piece of the cake and can eat it, like, because then we satisfy both concerns. So it's kind of, it's wanting to do the simplest thing, but it's very much been the philosophy of Crux just to really keep that core simple and lean. And you should see Crux as less of a sort of black box, but more of a customizable open box. And you can look at the core, you can extend it, you can augment it, you can play with it, and you can add to it.
So maybe on that note, then, actually, Jon, is like, what design principles are you kind of operating on? What are your kind of core goals with Crux?
I think. So one design goal is the layered architecture that we mentioned, and the whole layered design, the layered thinking is a thing in its own right. So that's one thing. The other thing is openness. So we really want Crux to be open. The architecture is open. It's unbundled. So we use Kafka as the event log, but we also swap out Kafka. We have a local event log that isn't quite as powerful, but if you just want to get going for your pet shop and play about, then you can use that. I'm sure someone in time will come up with,
Raft or something.
Yeah, like Pulsar, or just swap out Kafka something else, or Rats, whatever you just said. Raft. Cool. Don't know what that is, but it sounds cool.
It's a consensus algorithm, basically. Yeah.
Oh, okay, sweet. Yeah, why not? Like, there are some semantics that Kafka has. Like, it's this log of events and it's replayable. So as long as, because the way that Crux works is that you stand up a Crux node, it has a local database, a local sort of the indexes that we build that sits on top of a KV store. And the first thing that a Crux node will say is, hey, I haven't got any data, so I'm just going to replay it from this upstream event log that is also notionally part of Crux. And then it will use that sort of to keep itself informed, to keep up to date. So that open nature, you can swap out the Kafka bit if you want to for something else. You can swap out we build these bitemporal indexes on top of a KV store, and the two that we're shipping with is LMDB and RocksDB. And from the get-go, we actually provide a choice that they have slightly different characteristics. Rocks is faster to ingest, but LMDB is faster to query. Rocks is built by Facebook. It's tremendously sort of powerful. You can imagine all the development firepower it's had. But we like that idea of like Crux is this kind of framework of pluggable parts, and that openness precedes it. It's also open source. It's entirely open. And we want to try and have design conversations in the open and just get the community to be engaged. So openness in terms of communication, the source nature of it, the design nature of it, and yeah, that's a guiding principle. Yeah, I think those are the two that I would have. Jeremy's got some more design sort of guiding principles then. But, yeah.
Well, yeah, I just hope the foundations of Crux go on to enable us to build bigger and better things as a community enclosure and elsewhere. Crux, of course, is built in Clojure, but it does have a lot of Java interop, and been looking at doing a rewrite of the core in Rust to maybe get some shape for a little bit of performance. But fundamentally, it's a Clojure thing. But actually, we have a fully fledged Java API, and we think the capabilities that Crux offers are useful in so many domains and well outside of the Clojure community. which we're really excited to sort of bring to bear. And we think this is quite an untapped area of thinking, this whole bitemporality. So I almost feel like we're bringing bitemporality to the masses in a way that I don't think we've really seen delivered by others.
Yeah, I wanted to riff on before we leave bitemporality, because it is quite kind of dry on one sense and a little bit esoteric. And, if you're honest, you might have a question which is like, why do we really care? And I think it was Jeremy that really got me thinking about these particular sort of lines, which is that time is just fundamental. It's, if you think about what we do in software, we try and create a model that represents part of the real world, right? Mm-hmm. I mean, that's what we're doing. Yeah. And time is just, time is half of space-time. Like, time it's just so important. Like, it's fundamental to everything, right? It really is intrinsic. Yeah. And then, as Ray said, like at the start, he was sort of messing around, adding like database columns, like, I'm going to add like a time column on this table, time column, and that's a bit of slapdash. Maybe I need 2 or 3 more. Jeremy said, let's get a valid to, valid from. Let's all just have a big time frenzy party in our database model.
Yeah.
But isn't that weird? It's like, do you not ever stop to think, like, why am I doing this? Like, time is so fundamental, right?
Yeah.
It's like a database should support, it should help me with time. I shouldn't have to like do battle with time and have that friction. And we found that when you don't really stop to sort of model time and think about time, about what you need from time in your model and your tools, then you're sort of on the back foot. And then you're doing exactly that, like adding database columns in here, doing updates to mark which version was live on a particular point in time and all this sort of stuff. And we've all, most of us have done this. We've all added like various columns. But it's always that feeling that you're on the back foot and you're always catching up with time. Whereas if you think about time a bit more, like this bitemporal need, we've got valid time, we've got transaction time. What other time things do you need? What different pieces of functionality do you need? If you consider these up front, then you're on the front foot. And a lot of that complexity and time that costs you sort of having to put the complexity into these models to cope with time, you don't have to deal with, and you spend more time thinking about what the business needs, the functionality that you need to build for them.
I think just one more point on that, because I think time, I mean, funny enough, because we're doing like blockchain stuff, so time becomes things for us as well. And the biggest thing that that I like to talk about with time now is just the fact that in the 70s and in the 80s, when like the big databases kicked off, like, DB2 and Oracle and, Infomix and Ingress, and all those big guys, all the relational models, the reason they were how they were was mostly because of constraints in terms of storage, in terms of CPU and things like that. And obviously hardware and cloud and all this kind of stuff has moved massively in the last kind of like 10 years at least. But generally, the overall like arc of computing has been towards giving us the capabilities of freeing us from some of those fundamental constraints. And I think it feels a bit like people have been like this, like dog whipped into thinking that this is that these limits are kind of fundamental. But as you say, they're not. Time is actually fundamental. And we've been fighting against it for 30 or 40 years because we haven't had the firepower to deal with it.
Yeah, that's right. I mean, it's
cost, right? I mean, it was extremely costly. I think in one of the talks, Rich was talking about this place-oriented programming that we are using because of the cost. And I think people were, at least my limited experience was that people were thinking about the time. I remember in one of the projects, I was using Hibernate, and Hibernate has this automatic audit thing annotation for every entity. And it will create a different... for every entity, it will capture the information automatically. But the thing was that database was Oracle, so you don't have much control on how it evolves and whatever not, and it is also expensive to store like all this data. But the domain that I was working in was court related stuff, like the legal things. So everything is practically immutable, and everything had to be kept because it's a big international international criminal court sort of work. So that every transaction need to be audited or kept the data. And the biggest problem there was that none of the database was supporting because it was too expensive to store all this shit. It's because you keep a copy of everything. So that I think that's the thing. Yeah.
It's kind of fascinating when you start to look into the history of temporal databases, because in the 90s there were like these people like Richard Snodgrass, and they're proposing extensions to the SQL standard, which is like, okay, we need to have like system time where you can query as of system time. We need to have these temporal predicates.
Yeah.
But you can imagine, just like you said, it's like, the answer there is to store everything.
Yeah.
And in the 90s, they're like, what, are you crazy? Like, I'm going to store every fact, like a coral reef, like everything, and you can go back and forth. That's going to cost tons. I'm going to have to get somebody from Dell out or something to put a new rack into my put a new bit into my rack. It's going to cost me a fortune. Yeah. So they had these dreams in the 90s, and we've been looking at the papers, and we've been geeking out on it a little bit. And there's lots of interesting speculation back then, and they thought this was going to be the next big thing to free us, like you say, of these time constraints to help with this problem. But it turns out that it just didn't really take off, and it is like you are both saying, we think because of those cost implications.
Yeah. And so because we're talking about the architecture and because of the change, the underlying technology has changed a lot. So, we could do much different things. So whenever we're talking about databases, obviously CAP theorem comes up. So which out of CAP, what are you not providing in Crux? So consistency, or obviously it has to be consistent, like otherwise if I'm pushing the facts on them, I don't see that on the table. That's fucked up. And
no, I think consistency is always optional, actually. But okay, yeah, isn't that the point? Isn't it availability and partition, network partition?
Partition tolerance, yeah.
So I think the official answer is we sacrifice partition tolerance.
Okay.
I would like to double check that. I'm pretty sure that's right.
I don't think that's right, because you're using Kafka, so that doesn't sound right. And you've got multiple nodes. So my guess is that you're not so concerned about consistency.
We have consistency as of the transaction time, because the transaction time is set when it goes into Kafka.
Yeah,
but consistency is like atomic transactions and serializability and all this kind of stuff,
Yeah,
that's when you get into like complicated conversations about time, actually. And I think we can really go into that. Actually, but why not? Fuck it, Because I think it's a bit of a nightmare. Serializability and this whole the definition of serializability and like repeatable reads and all these kind of things. They're all a lot of horseshit. They're not really well standardized, actually.
So the way Crux works is everything is written to a single Kafka partition. All the transactions are written to a single Kafka transaction partition. So they have to be serialized. And so the coordination is really about who gets there first. So by using CAS, compare and swap, and retries, that's how the nodes coordinate. There is no sort of communication between the nodes to coordinate writes to that transaction partition.
So can you?
But the simple point is like the kind of like numbers 0 to 10, yeah. And I'm writing 0, and then VJ is writing 1, John is writing 2, and you're writing 3, Jeremy. So we're all. How do we order these things? So I go first. How do you make sure that it's all ordered in the right way?
Yeah, that's
Kafka's a big problem, I think. Yeah.
Well, it's the point of when it goes on to Kafka. So Kafka gives us that guaranteed ordering, and then you can guarantee that all of the Crux nodes are going to pick up the transactions in the same order.
But
then you deal with the valid time, I guess, as a sort of mechanism for dealing with this straggler problem.
Yes.
Kafka doesn't do that, right? Because if you have multiple producers, I'm assuming every maybe I need to understand.
It does order things, actually.
No,
there is no partition. It does.
No, per partition, yes, there is an order. In I'm not talking about the order in which you put in and then you read, you get the same order. That's okay if you have one partition.
Cool.
But if you have multiple producers and they're writing, it's first one wins. That's it. The data that enters into partition is based on which producer is trying to connect first.
Yeah, and that's actually, funnily enough, where bitemporality does come into play. because like we've had this situation at a large investment bank, and they have this cutoff at 5 o'clock, and that's the end of day, right? Like at 5 o'clock, they want to draw a line in the sand and say, for all that data that we've had throughout the day thus far, we want to use this to calculate our P&L reports, who gets a bonus, whatever, what's our risk exposure, all that stuff done on this 5 o'clock cutoff.
Yeah.
But the problem is, as you say, it's like in the real world, it's like, well, crap, there's like a data center in Hong Kong, there's a front office system inside the US, and they're spread all across the world. So the data does arrive out of order, and it's a little bit jumbled up, like it will get on some message bus in the middle and massage, whatever. So by the time it gets into your system, it's a little bit all over the place. And then at least if you've got valid time, then you can use that to your advantage because you sort of reorder it after the fact. So you say, well, let's give some window of like, sort of 5 o'clock as a cutoff day plus 5 minutes of transaction time beyond that. And then within that, we'll then query against valid time, and that should be our end of day.
So where is this transaction time coming from? Because if I have multiple nodes, multiple producers, which are actually writing the same partition, is the transaction time, because Kafka doesn't add anything, right? It's just bytes in, bytes out. Kafka doesn't care what kind of data that you're putting in. So it cannot add anything there. So is the transaction time coming from the nodes themselves?
No, Kafka does have like the messages get stamped when they go onto Kafka with a timestamp, and we use that for the valid time.
You only get the message ID, right? Because you only get the offset.
No, it has a timestamp associated with the event of going on to Kafka as well. There's metadata on the Kafka messages.
Yeah, there is metadata, of course. So the transaction time is basically Kafka, or the time when you receive into the queue. Receive into the topic.
Yeah.
So you can use the valid time to put more information to say, okay, this has happened first than the other one, because your domain knows what is first.
Yeah. You're right that the messages definitely do have an offset. I need to check exactly how that offset sort of gels with the transaction time, but the transaction time definitely is from the point it hits Kafka.
Okay.
And then you can use that to get some measure of consistency when you do reads across those nodes.
The consistency is sorry. Go on, Vijay.
Yeah, this is a very interesting design because I spent a lot of time with Kafka, so I had some fun with it. Before they added this authentication and SSL-based stuff, especially we had to use it at a bank, and that was much more funky, securing it. That's why I'm curious about using Kafka as the data store, because then that means I need to keep my the persistence for Kafka is essentially forever in that case, right? Because you're using it as a data store.
That's right.
Okay, so that. Because that is some use case that I haven't thought about before. Because usually when you use Kafka, you're using it as a quote unquote message bus. So you have like 7 days or 8 days of data, and then persistence per topic. You can decide that one as well. So why Kafka? Why not something like Foundation DB or something like a different store?
I'll give it a go. Although you're probably more qualified, but I think Kafka, because of its because it is log oriented, there's I guess less overhead in storage. Yes, you're right that the common use case for Kafka doesn't have this unlimited retention, and if you look at most of the managed Kafka hosting options, they don't offer unlimited retention. And I know it's an evolving story as well, exactly how efficiently Kafka can support that. So John mentioned Pulsar earlier. There are other options which provide very similar APIs that we had used from Crux to do that log storage. So Kafka was just something we were familiar with and could get working quickly. But John, did you have another angle?
Well, Kafka does offer it does offer the infinite retention.
Of course.
So that's what's advertised. So it is something that we can take advantage of. It does go against like the common use case. But the way that so one thing we haven't really seeing as we're sort of getting into detail in Kafka, I feel like I want to throw up the other big design feature of Crux, which is that the Crux operates with two different topics. So let's say that you're throwing a document into Crux, right? Job done, you're sort of happy. That document, what you will do is that you'll fashion up a transaction. So you'll say, I want to put this document into Crux. So that transaction will go onto the transaction topic. And that topic is going to be quite small by default because the content, the documents go onto a different topic, right?
Yeah.
That's why we can sort of hopefully get away for quite a long time with having a single partition for the transaction topic. But the content's gone to a different topic, and we've got more options there potentially with sharding and also compaction, because the key on that document topic is a hash of the document.
Yeah.
So we'll get some ease of compaction, ease of duplication, which is a mini sort of feature for free in a way.
Yeah.
But the main reason that we designed this is really to be able to evict data in a clean way. So the transaction log's immutable. Like you can't change the transactions, but all a transaction has is like a pointer to the hash of a document, and that lives on the content topic, the document topic. So then it's kind of built from the ground up for this use case of like GDPR, etc., where you can evict. So you can go to a Crux node and say, I want to evict this document, and then it will cleanse it from that Kafka document log.
Yeah. And how does that work when you're replaying? Because if I understand correctly, so you send an evict command or something, and then that gets into transaction, and the real document gets evicted from Kafka.
Yeah.
How does it work when you're replaying? Because then it will, when you're catching up from assuming that there is another node that just starts up, obviously Kafka will start sending, okay, this is the first item, so start. Yeah. So how does that work?
Yeah, I mean, it's definitely a bit of nuance there. So really, the document has to get killed from 3 different places. Like the document topic, that's the main place we have to worry about. You can send a nil, I think, into Kafka, for this message, for this hash, and then it will kill it.
Yeah.
Then we have to evict it from the underlying KV store as well, which is like the local nodes kind of storage. And then we have to evict it from a cache, like the caches that we have inside of Crux between the document storage and the query engine. So we have to do all those things. I think when you replay it, like when you replay the transaction log, it just points at a document. There is some synchronization inside of the Crux indexing process. So the transaction is pointing at documents. Crux will sort of hang on until it's got the documents that have been pointed at by the transactions. But then when a transaction sort of comes in, and we know that document isn't there because there's a nil essentially for that document. Then it will just not index it. It will just say, look, this document doesn't exist. I can't index it.
Okay.
One of the interesting things about Kafka, though, I mean, that I think that again, I mean, I remember back in the day, talking about like hundreds of transactions per second. Everyone was like, we got Oracle to 100 transactions a second, or 200 transactions a second, and now we're looking at like thousands of transactions a second, on a node. Never mind overall. So I mean, what have you done any load testing on this thing? Because it must be pretty good at ingesting stuff.
Yeah, I mean, we want. Let me go in a slightly different direction to answer that question. So you asked me about design principles at the start. I sort of neglected to, scaling is important for this project. Like, we want this to scale with lots of data, and the unbundled. I will get to answer your question, right? But
it's fine, yeah.
But the unbundled.
You can ignore it as well.
It's going to drone on now forever.
I want my question answered, John. Come on. This is a Today program,
No, you can fuck your answer. I'm going to go on my own spin now. But the unbundled nature of Crux basically helps you scale, right? Because you can say, look, I don't much care for Kafka. I want to use my local sort of version that we ship with that you can use. Or maybe maybe you'll take on the burden of writing to fulfill the protocol, some other implementation that doesn't use Kafka, but something a bit more lightweight. But the point is that you can scale up, like the unbundled nature and the pluggability of it means you can swap out the components. And as you need more power, you then make use of RocksDB, which the people at Facebook have built to scale extremely well. So that's just one nice thing about scalability. When it's open, you got options to scale. The other scalability point is around the indexing. So using RocksDB, the algorithms at the heart, they might not be like the nippiest out the door for small data sets, but then it really comes into its own when you've got like lots and lots of data, because the query sort of compiles to kind of indexes against the underlying KV store, which, by the way, a nice side effect of that is that the results are lazily streamed from the query engine. So you don't have to materialize all of the data in memory and then pass it through each clause. It just comes from the query engine in a funky way. Yeah, so that's scaling, and then so there's a sort of full-blown Crux topology that we might envisage, where you got Kafka, and then you've got something like ROX or LMDB that's backing up those KV stores with the query engine on top. That is built to scale. We have been load testing it, so we load tested it. We've load tested different products just to get a feel for it. We've used test suites, not just our own. So we started off like my first commits were adding some shitty tests, and then like we went around and Håkan said, no, we need to be a bit more professional in this rather than sort of foobar. Let's see what's actually in the industry. So we went and we took some tests. Jeremy's going to be much better to sort of name them, but we took some from the University of Waterloo, which really sort of test the graph queries kind of at scale. So it sort of like sweats them as well. Like it gets really sort of difficult join condition graph queries and then puts enough volume through those to stress them. And the idea is that if you can create a graph query engine that can sort of fulfill all of these different WhatDiv tests, then you're in a pretty good shape. And there's also these lub tests as well. Jeremy, can you just pitch in and describe the test? I think it's quite interesting. It's worth...
Yeah, well, but so both of these test suites are actually sort of RDF-based tests. So they're designed for testing traditional RDF triple stores. But essentially, this sort of property graph index RDF dualism, it means that we can very easily adapt these RDF tests. So that's what's been done. So I think the official academic sort of definition for what kind of graph query there is like a subgraph isomorphism. Or graph pattern matching, but yeah, all these test suites, they're testing the ability for Crux to handle like these just absurdly complex queries, but also these ones of very different shapes. So well beyond like an actual use case, because they're all generative tests. So they're some of these tests like take minutes to complete a single query. So they really like max out the amount of memory. Some of them time out, and that's kind of on purpose. That they're real stress tests. So there's a whole range of stuff. But by doing comparative testing with Sail, which is like an RDF open source Java thing, we've been able to validate that actually, Crux is doing quite well against the state of the art in this space.
So I have, I think, two questions. About one about scalability and one about testing. So I think I'll start with the scalability thing. So you said by design, I can understand that transaction topic needs to be one partition, obviously, because you want to keep the order. What about the documents topic? I mean, because one of the things with Kafka is that if I'm trying to start a cluster, then I need to decide what is the how many replicas I need per partition. So that is usually how much of this is leaking through Crux design, or is it completely under my control as an administrator? So I can decide, okay, document topic can have 50 partitions, and then I can decide because one of the issues or one of the design problems with Kafka is that if the partition becomes super big, then it's not really easy to bring in new brokers into the system because everything needs to be caught up. And there is always one leader partition, so everything connects to the same thing, same machine. So how much does Crux enforce single topic or single partition thing for document store?
I think right now you can set Kafka up yourself, and then Crux can just consume off it. So it's up to you how you configure it. You are right in that from the get-go, we expect those single topics. Okay. But then I think as we grow, as the Crux project matures, there's definitely things that we can do on the content topic. And sharding is on the roadmap as well. So it's something that we want to we want to really investigate and just listen as well. We want to understand, speak to people like yourself and just get a better feel for what options we've got.
But I really like that the pitch that you made, or the design decision that you guys made, that you can optionally replace Kafka and then introduce your own layer there. I think that is like a really nice idea, because as you said, I can replace it with Foundation DB or something else that I think, not me. I'm not that smart. I'm just talking bullshit probably.
No, I know it's
no,
it's entirely like there are closure protocols, and
okay,
as long as you Kafka has the semantics of the replayability and helps with eviction, and it has those qualities. But if you can fulfill that contract, then you can swap it out, and that'll be an amazing day. That'll be awesome if that happens.
Awesome. So the other question that I had was, because you were talking about testing, are you considering doing like what's called a Jepsen, Jespin from Afair? Sorry, I only know his name from.
Maybe.
Yeah, Call Me Maybe. Or
Afair.
What is his name? Shit.
Kyle.
Yeah, Kyle Kingsbury. Sorry.
Kyle Kingsbury, yeah.
Holy fuck. So are you planning to do any tests using Jepsen? Because I think he tests for the split brain issues and network stuff and other stuff as well.
Yeah, I think I'll just jump in there, but we did look at that, but then Crux isn't actually a distributed database in the rawest form, because the node's a single writer. So the queries aren't distributed in a way that I think the Jepsen test would test for.
Okay.
That's my understanding.
Yeah, I think that's right. There are, again, like sort of nuances when you would have lots of nodes. You'd want to use valid time as well as transaction time to run your queries, to make sure that let's say you're using the HTTP interface, that the node you're talking to is using a version of the database which exists across other nodes, because your query might go to different nodes at different points in time. But essentially, there's no distributed query going on. It's not dgraph. It's a much simpler model.
Actually, that's worth mentioning just briefly before we skim over it. There is this. You can ship it in different ways. So you can put it as a jar file in your project, and that is it. Like, everything is local. The KV store, the replacement for Kafka, that's local. Happy Days, like your SQLite thing. But then if you wanted to, you could then it ships with a HTTP server. So you can still do that where you fire up a Crux node somewhere and it has a HTTP server, and then Crux ships like a HTTP client that you can call to do those calls. Or you can go full blown and have like a suite of Crux nodes behind a load balancer feeding off the event log Kafka, and then your app can call them. Or you can ship your applications as Crux nodes, as Crux an embedded jar file, and then it then just subscribes and starts getting those updates and builds up the local data that it needs.
That's pretty cool. That means you can just have like, if I have one application that is using Crux, then I can ship another application embedded Crux, and then they can connect to the same data store, and then okay.
It's like the original version or vision for databases. Multiple applications using the same database.
Yeah.
So what are the kind of like what are you thinking in terms of like the operation? No, what are you thinking? No, in terms of the operational model. So you mentioned like a couple there, but I mean, are you kind of like prescribing or preferring a couple in the early days?
I wouldn't go that far. I think we'd say that we're a little less keen on our homegrown event log as opposed to Kafka. But we recognize that people want to get on and play, and then have something that is, that they can just work with as a get-go. I mean, the local one does have the backup and restore capability as well, so it should be battle tested. But we'd expect, like, for serious use, then right now the main option is Kafka as the event log. But then I dare say that I don't think we have any strong opinion as to whether you would always say Crux has always got to be like its own HTTP server thing, and I always communicate via REST to use it. I think we're ambivalent on whether you want to do that, which is fine, you can do that, or whether you just want to ship your application as like these single instances that wrap Crux as a library, and then it spins up the local data on disk. I think both are okay. There is some backup and restore stuff in there, so a node, if it fires up fresh, it doesn't have to sort of replay everything from Kafka. The idea is it can feed off a backup that's been made at some point using a snapshot.
Okay. So the reading part, so you have a different query language, if I understand correctly, or like a what kind of query language you use to query all this data that you're storing in?
So it's Eden. So it's Eden flavored data log. So it will look familiar to many people in the Clojure community, but there are some differences. The primary difference is actually the fact you can't query using sort of wildcard attributes.
Okay.
So you have to define your attributes in the query. You can't say show me all the attributes relating to this entity. You'd have to go to the document to look for that.
Yeah, because you don't have a schema to look up all the stuff. So obviously that's the.
So it's document by document example type thing.
Yeah, and of course you could you can query the the statistics. So Crux records the statistics of the attributes that are indexed and ingested. So you can look at attributes that are in the database, but just not that there's just isn't a specific for a given entity. Show me all the attributes it has index. So it's got two primary indexes for.
Yeah, I think it's worth saying that data log that we support is inspired by Datomics and Datascripts, but it's not compatible, so you couldn't take an app and just use it straight away. One of the main reasons is coming back to this layered. We just want to get the basics, the fundamentals right. So there's lots of stuff that we could imagine be written as decorators. We might supply some decorators ourselves as part of Crux, part of the Crux repo, but we're intentionally not doing a one-for-one to sort of support everything because we see it as layered. It's like you've got Crux, and then you can add some helpers. You can riff on those, and people can contribute different ones.
And if I understand the design correctly, the query engine or the reading stuff will never hit Kafka because it is always going to either RocksDB or LMDB. Is that right?
That's right.
Yeah.
Okay.
It's also worth noting that it's always querying a single point in this valid time transaction time continuum. So it's not querying a range within that continuum.
Okay.
So it's not like oh man, what's it called? That database where you could essentially give a query and it would do live updates.
Like a stream.
Like a stream.
In MongoDB, for example.
No, there was another one, wasn't it? The one that
Rethink?
got burned. Rethink DB, that's it. Yeah.
It actually pushes the data to you, right? We can just keep the connection.
So you make essentially a query on a view, and if that view changes, then the data gets updated in that view. But you're not like that. You're basically saying that you take a snapshot essentially, and then if things change. Do you get alerted if change? Because that's one of the nice things about event systems, I think. I mean, it's one of the things I was kind of have been a bit passionate about over the years is that, I don't want to necessarily have to constantly query back to the database all the time. One of the things Rethink DB was nice about was that you could make a query, and then if one small bit of data changes, it would come to you. It would tell you, or you're a listener on that view. And I think Datomic has the ability to, you can register like a transaction listener essentially to say, okay, if that schema changes or that bit of data changes, then tell me about it. Do you have something kind of similar to that, or where you can listen to transactional events? Yeah.
So I think there's two levels to this. So the first is, like at the granularity of a document, you can absolutely listen to the transaction log. We don't have like a trivial way or like a pre-canned way of doing this, but certainly the hooks are there, the API is there to listen to the transaction log, filter it for just the document hashes that you're interested in, and then react to those, of course. And then I guess the other level you're asking about is for want of a better term, streaming data log, which is essentially this differential data flow research, which is going on, and Nico and others are building 3DF and sort of solutions in this area, and those aren't incompatible with Crux, but Crux is more of a traditional database. It doesn't offer streaming queries, but I'd say that differential data flow stuff is so academic still that it wouldn't cover the same range of data log queries that Crux is able to. So maybe you could do a subset, and the data log could be quite similar. So if you had the two running side by side, you could get the best of both worlds.
Yeah.
So
I think again, it's like one of these things where, because you've left it nice and open, you probably got the ability to eventually layer that on top. By the sound of things, it's not like a closed up operation.
Yeah, that's really the answer that I was going to suggest as well. And the sort of layered kind of openness, we would typically always just say, well, develop a Crux access pattern. Like you can put a Crux node out there that then listens at a lower level, sees the changes, and then reacts to it on a way that then can present it to some other system.
I mean, the nice thing about it is that you've kind of because one of the things that is kind of annoying about traditional databases is that, or in the past anyway, now we're breaking all these walls down. Like the fourth wall was time, So, and the other one is like this transaction stuff. So all the kind of APIs that the database vendors had access to, but you didn't have access to, because you've unbundled it. You've done the Martin Kleppmann thing, inverted the database. You've now got access to the sort of transaction stuff. Then, like I say, you can layer stuff on top of that as you wish, really. So that's a nice thing, because you've given us access to all the actual raw data. Then
you could even, if you wanted to, like read the Kafka and get in between yourself and Crux. There's a myriad of possibilities. I'm sure there's more work. Like right now, the bytes are serialized using Nippy onto Kafka, so there's a degree of openness that isn't quite open, and we've got a GitHub issue about maybe changing the serialization format or whatever. We need to consider that. But yeah, fundamentally, it's kind of opens, so you can pick and choose and get in there and weave and change things.
Probably one last question from me about the Kafka related thing is that. So how does the read scalability work? Because if you have one partition, then essentially you can only have one consumer, because every consumer connects to one. I mean, in a group, you can only have one consumer. The rest of the consumers don't do jack shit if I don't have multiple partitions. So how does the read scalability? Did you do any tests on how much it is going to scale in terms of reading? And related to that one, for example, if I have because Kafka is pull model, so consumer needs to pull the data, so Kafka is going to let you know. So that means there is some level of delay, quote unquote delay, because you need to trigger this polling mechanism and processing mechanism. So how does these things work, or what is your design choice here?
Just in reverse order, because the first question was hard. But
well, you're not reading directly from Kafka, so just.
No, I mean to sync your RocksDB, you need to read from the Kafka, right? That's story.
Yeah. So you can sync. So you can say like wait until you've caught up to this particular transaction time.
Okay.
And then if you have like a gatekeeper kind of Crux node where for some reason you want to block until a write has been made, then you can do that. You can say like I only want to carry on writing once I know that it's made it all the way through a Kafka and my local RocksDB has been updated, it's ingested, and now it's up to date, so I can carry on.
Yeah.
So you can weave in that back pressure.
Okay. Yeah, because that's an interesting point, right? Because you have Kafka, and I know Kafka design choices. They're like, okay, this is not our priority, so we're not going to do this, because that's why Kafka is so simple to understand for even folks like me, that they made a really simple design, so to speak, to understand. And if I'm writing to Kafka, then I can say, okay, make sure that all the brokers are in sync, so then only acknowledge or something. so I can guarantee that it has been replicated.
Yeah.
But do you cover the transaction, so to speak, from if I have 7 nodes of Crux,
Yep.
and I push from one node some data, can I say that acknowledge when this is actually in all the RocksDB level, not just Kafka?
You can acknowledge when it's got to you.
Okay.
So it's gone into Kafka and then it's come back, and you can block until it's got to you. What you can't do right now is ensure that every single Crux node has got that data. We don't have a mechanism to cope with the fact that for some reason there's a Crux node that's on bad hardware or some micro instance, and it's just slow.
Normally it's like a replication factor, isn't it? Anyway, you're never going to get full duplication. Most systems don't offer that. In fact, I don't know any system that operates that.
In Kafka, you can say that. You can say only let me know when, if I have a replication factor of 5, then acknowledge when all the replicas have been received the message.
Yeah, of the 5, but normally we're running 10 or 20 though.
No, that's based on your replication factor. If I have 10 nodes, I can say replication factor of 5. Then I can say, 5 and 5, or I can say 1 node, or I can say all the 5.
That's cool.
But that is like the Kafka level thing, not. One thing, John, I mean, I by just looking at the image, I mean, it was very easy to understand, like, how you designed this one. So I really appreciate, like, it's the first part that you put in the website, like openness, that was very evident from the design. So I understand it's still in beta, so maybe I'm asking some stupid questions that I don't understand. But
it's actually in alpha, so we've got a way to go. It's like I just thought you use it your own risk.
So the biggest question, or probably the first thing, probably everybody who is familiar with Clojure that comes to their mind is like, how does it compare with Datomic? So,
well, I think for the fact it's completely alpha and it's not mature, and you use it at your own risk. I mean, that's the obvious point, but then let's go through the differences. It's schemaless. Datomic enforces a schema, which is pros and cons. Like both tools, I believe, have some sharp edges. So you can cut yourself on any tool. But one of the sharp edges of Crux is that the data can be inconsistent because we don't enforce a schema. The other one is you've highlighted. Right now we're shipping with Kafka for serious usage, and that's going to put some people off. There are some trade-offs with Kafka. It's kind of heavy. So there's that sort of thing to add in. The Datomic story is kind of, I mean, we are inspired by Datomic. Like Datomic is really sort of the fact of bringing your data close to your application. We've used Datomic a lot, and it's that awesome sort of rapid development story that it comes with. It's fantastic. It's really embracing the cloud with ions. So I dare say that if you want a mature cloud story, then the money would probably be with Datomic. And also the API is different. Datomic is going to be far more polished. There's going to be more in the data log that you can get access to. Crux, you might have some false starts because we come with a fair bit out the box, but then there'll be helpers and APIs that people add, and there'll be some stuff in the community. So it really is for the schemaless. We pay a bitemporal tax just in terms of. We had some conversations early on, which is do we really advertise the fact it's bitemporal? Because a lot of people would be like, what? It's just, I mean, what is that? It's a hard sell, but we've chosen to double down on it in our architecture. And there is a bitemporal tax. It's complexity in terms of our indexer has to work hard to maintain those bitemporal indexes. So it's a little bit more. The tool is taking on more complexity, so arguably you don't have to, but you got to work out if you want your tool to be doing that. So I think we can present what Crux is. It's inspired by Datomic and Datescript and other things, but there's enough differences there, and I think those differences will evolve, and time will ultimately tell, like in which case one particular tool is better than the other. I mean, I'm sure Datomic now, for the fact it's not alpha, is probably a wiser choice.
Well, I mean, obviously, it's because we're talking about time. I mean, at this instance, it is alpha, but it is going to move to production level pretty soon, obviously. So that's just an instantaneous state.
Yeah, hopefully. I mean, if you want some good news about Crux, it's that we launched Crux last week, and there is that thought. Coming on this podcast as well, it's that thought, which is, what if we've just made a bad choice, or there's something that someone will point out, and it's like, oh yeah, actually that's pretty shockingly bad. It's no one's fault, but we don't know everything. We're only human, but we've got something wrong, and okay, let's just move on, or we're going to take a lot longer to sort of change something that's fundamentally incorrect. I'm sure there's big things we need to work on. We've got some things in the roadmap, and it's a start. It's right at the start of a journey.
Yeah.
But so far, at least, my big fear is that it's just something's unearthed. That's the unknown unknown. That's going to mean that it's an invalid design. And thankfully, we haven't had something as fundamental as that occur yet. But I welcome, let's get the feedback. It needs to be battle tested in the real world. I mean, that's the big sort of elephant in the room. In that there's not actually that many people using Crux, and we're starting to get people on the mailing lists. We haven't used it in serious anger yet on production systems. We have used it internally, playing about with it, we stress tested it, but it's alpha. So it's right now it is a bit of a leap of faith. It's a bit of a gamble, and just look forward to the day when we can reflect and say nothing's ever truly stable, but at least it's got a bit of experience under its belt.
Well, there's definitely plenty of room for more databases in this space. I mean, it would be crazy if there was only ever one database that the Clojurians looked for, I think, and I think you've taken a different tack, like you say, you've taken a much more kind of open approach, a much more modular approach in many ways, or openly modular approach anyway. But I think, everything should be possible. I don't think that the people at the Atomic are saying no one else should ever make a database. That would be weird.
Yeah.
It would be weird, and
they're allowed to do that.
I think it's got to be good for Clojure that people try stuff as well, and the different ideas. And we want Clojure, don't we? We want Clojure to be known as having these awesome applications.
Yeah.
Unless Jeremy and Håkan rewrite bits of it in Rust, but that's a different conversation. But
I think the other thing that's interesting, I mean, it's kind of like a weird thing, but I remember like this, I don't know if it's an absolute statistic or if it's just something I've misremembered, but I think Stu once said that there's only like 1 or 2 atoms in the whole of the Atomic or something. Did you find anything, because you mentioned Clojure, I mean, did you find anything about the Clojure, the designing and making it in Clojure, that was specifically delightful or surprising, or was it just like everything you knew about Clojure just was brought to bear on this project?
I think Clojure is good for the ideas and playing around and implementing the algorithms that we found in the various white papers that we consulted. So Clojure is seen as that. Let's build it in Clojure to start with. But then we've had to rewrite bits in Java as they ossify. And then I think ultimately, do we then take the sort of very core bits and maybe try Rust because it's quite good fun to see how fast we can make this as well.
Yeah, sure.
So Clojure seen as that sort of that's let's just let the thinking flow and take it from there. And just that low friction as well. Like you could argue the schemaless, the dynamic nature of it, we sort of embraced as well.
Well, I'm guessing you're getting leveraging a lot of the performance from the infrastructure as well. Yeah. Like RocksDB and Kafka, they've all got awesome performance, and often
they have.
The way I find it, maybe there's some tight loops in your code that you could optimize, but probably a lot of it is just
It's quite interesting, like when you dig into it, and it's actually quite fascinating because actually seeking around on so imagine you just have a index which is a bitemporal index, and it's just a KV source, so you have a key path, so you've got all these different keys sort of lined up against each other. And what you really want to avoid is too many seeks, because each time you sort of just don't do a next, you actually do a seek, a jump. That's expensive. And the way that it works is that we are doing a lot of seeks. So then, I mean, Håkan, he's just amazing, really. I've worked with him for kind of 14 years, and a bit of a mentor to me. Like, if I could be as good a coder as him, I'd be happy. I mean, it's not going to happen, let's be honest. But he's been experimenting with, the RocksDB driver that came out the box. The JNI wasn't fast enough, so he tried to write his own in C, and just to really speed up, because RocksDB by default it uses the byte arrays, uses the raw byte arrays, but then they're copied when it actually gets into closure land, like that bridge from C to the JVM, the byte array is copied. So can we use like the heap byte buffers instead, where that underlying byte array from C is preserved? But then that wasn't fast enough, so let's build our own sort of C variant that does a better job. And it's just trying to really maximize the potential there. RocksDB, the Kafka guys, the Confluent guys, I happen to know, they're occasionally looking to move away from RocksDB to LMDB. And one of those reasons is that the people at Facebook have geeked out on the configuration possibilities of Rocks. So, if you start reading it, it's like, oh my word, how many config options and column families, and we could spend months just optimizing Rocks. What we're actually looking to do is we're looking at different algorithms as well that could potentially replace the one we're using or augment, just to get different speed benefits in different ways. But we're always conscious that we are paying a bit of a bitemporal tax, because we have to maintain these more complex indices. So we have to be quite careful and think for a long time before we want to pull a different algorithm in.
Actually, didn't Michael Dragalis go and work for the Kafka people?
Yeah, Pyro Store.
Yeah, they were doing a similar. No, but it wasn't anything like what you're doing, but they had some kind of like,
It is similar, right? Because data storage, obviously, everything is anything that stores data. But
didn't he do something with S3 and the retention?
Yeah, exactly.
The sort of
from Kafka to automatically to store S3 PyroStore.
Yeah,
that's like a storage mechanism. You don't care whether it is coming from Kafka or S3. So you can just write something as a PyroStore like on top of that one.
It's super interesting for us. Definitely want to chat to him.
Fairly similar, but I think a bit more different. I think probably same difference. So, what is the role of Juxt in this project now? So, where are you? Where do you fit into this thing? I know it's an open source project. That's amazing. That lets people, experiment with the code, or maybe even build features and then take it into, as you said, layered approach. So it makes much more sense. So,
I think Juxt
doing in the project, or not doing, fuck it. The direction that Juxt wants to take this one into.
I think Juxt is, it's like a department within Juxt, which is the R&D department, and Jeremy sort of heads it up. And we're building out Crux, and we have a team, we have stand-ups, we have a roadmap, we have a tech lead, we have a process. So from that perspective, it's just like a project that like you would have. It's like a client project in a way. It's kind of managed the same way and resourced the same way. But I think we see Juxt long term. It'd just be nice to sort of diversify a bit. Consulting is what feeds us. Like we get experience from our projects and real world sort of application of software. That's really what teaches us and sort of gives us insights. Although I was thinking today, it's like every time I speak to a client these days, it's like I should be paying them for like what they know. It's quite
like reverse consulting.
It's just amazing. That's potentially a danger of Crux, is that we attract clients who are just so far out of our league. It's like, well, let's learn from you for a bit. But yeah, I think Juxt, we want to diversify, and I think it's fun to have a product. Consulting is difficult. It can burn some people out because you're always at that early stage of the software delivery lifecycle. At the start where you're the ones that are sort of hitting the ground running, putting in the energy, building stuff, and then over time you'll sort of phase yourself out. Or those people that were involved driving it in the high energy, they go on to the next project, and it's expected for them to go again to drive the high energy. So I think having a product, something just different, I think it just really helped people to rotate around and just get a different perspective, a different pace, and it kind of keeps it all a bit fresh. And they also feed in, like Crux will help us to attract clients with different problems, and then when we get those clients, because we're learning about Crux, we're having these conversations, like we've talked about lots of different technologies and products tonight. That's good for us, because then we can talk to our clients about those. So it's kind of like a symbiotic relationship.
Yeah,
and it's just fun as well. It's it's different as well.
How do you see the community participation in the project?
How do we see it?
Yeah.
Well, we can hope. We hope that people give it a go. A little bit sort of it's completely early. So as I mentioned, there's a bit of a fear that people come on and say, "God, what have you built? This is ridiculous." But that hasn't happened, thankfully, yet. Although we welcome that, of course. But no, we just want people to play with it. That open, extensible nature of Crux. We'd be really pleased to see a kind of repo spring up on GitHub where someone's like rewrote the sort of data log or extended it, and then that could be really cool. And it might be that we have conversations and we find ways to learn from each other. We take some of that into Crux, or we respectfully just say, no, use this if you want this particular feature, this person's library. And that'd be really nice to think, who knows where Crux could go. Like if it could hopefully grow beyond Jux, like beyond our design. Like, let's get it out there. The community will adopt it. It will sort of morph into something more exciting. As Jeremy mentioned, the sort of data flow, what's it called? The 3DF guys. There's different futures, there's different possibilities, and it's more exciting just to launch something out there, not necessarily know where it will go, but just know that you're at least going on an interesting journey.
Yeah.
So in theory, I mean, it could be, like you said, people could pick it up and embed it in their ideas and take it forward that way, as well as being a product that someone can use like on its own.
Yeah, it's like you could wrap it, you can extend it. There's different possibilities.
Yeah, it's fantastic.
I mean, it is also a product in the sense that we're going to offer support for it.
Right.
And that should give people a bit of confidence that it's a bit of a safe bet, because, well, hopefully, if it stands up to the test of time, but it should give people some confidence that we're going to invest in it. And I'd love to get to a point where it's sustainable and there's like 5 or 6 people on it and just having a wonderful time and taking ideas and just extending it.
Yeah.
And that'd be lovely.
That's amazing. So, did we miss anything in our questions? Or
we probably missed loads of stuff.
Probably, but
we've just been going for. I just noticed that we've been going for an hour.
Last thing I want the podcast
it's
to
so
be.
Easy to talk to you guys about this tech. Really is, yeah.
Yeah.
So I'd say that the only thing that maybe we haven't touched on too much is like all the different things you can do with bitemporality. Like, what are the actual applied use cases? And I've tried to document as many as I can think of and find out in the wild in the docs. So there's use cases across loads of different industries, whether it's financial services, healthcare, law, but arguably those are the places where you need bitemporality, like where you'd be sort of foolish to not use it. But arguably it'll just make development simpler, prototyping easier, and I know there's active research really going on with like bitemporal event sourcing and these kinds of things, and I think there's a whole world of possibilities yet to be uncovered.
Awesome. I think we are. I'm just checking the time. Oh, 1.5 hours. Okay, that's a significant amount of time. Obviously, my brain can't focus more than 30 minutes or something. So probably after 30 minutes, whatever I said is probably bullshit. So that's fine. Thanks a lot for open sourcing this one. That's like a pretty good thing. As you said, John, must be amazing code. So there is a lot to learn from. I think probably from the community and also from, as you said, reverse consulting from the community as well. That would be amazing, and I'm really curious to try it out, because I looked into the documentation a bit the last couple of days, and I'm really, at least I would be at least trying it out, because this is one of the problems that I've been following for long. And DataMake, one of the things is that price and openness and that issue that we discussed multiple times. And I know that Mozilla has something at some point, like a DataMake implementation in Rust or something, and then that was an abandoned project again. I forgot the name.
Was that Mentat or?
Yeah, something like that. Yeah.
Yeah, that looks quite cool.
And DataScript, obviously, still flourishing. It's going on, and Nikita did a great job in that one. But still, DataScript, sounds like it's on a browser sort of thing, and it's not really like scalable back thing.
I think with Dataflow and Mentat and DataScript, I mean, there's a lot of work going into DataScript. It's now funded by Clojurists together.
Yeah.
I think you could arguably say it's a mini wave of things happening in this space.
Yeah, but you're filling a very, very specific area that we don't have a tool for, or at least not enough choice available. So this fits right in, especially with the things that you explained with you both explained with the bitemporality thing that I think I finally understood a bit. I think I'd love to see this project grow and then get more users and more use cases and all that stuff and more community participation. That would be amazing. And hopefully you'll be offering it as a that's what Jeremy said, like an offering manager.
Yeah. Offering it as a service or as a supported product. Yeah,
that would be amazing. Having a smart guys like you providing the support for that makes it much more lucrative. So I think that's pretty much what I have in my list to ask. Ray, do you have any other comments or questions?
Well, there's lots to talk about. Like we've said, I mean, it's so easy to talk. We could probably go on for a few hours. I mean, I think my thinking is, we should have these guys back on in, let's say, a year's time to review what's happened. See, it's going to be like a great wave at the beginning and a lot of enthusiasm. And I'm definitely very keen to use it for sure. Let's see what happens in a year where the design is taking you guys. I'm really excited for you. I think it's great. I love you guys, so I think you're doing great stuff. I'm very excited about this product. I know you've been cooking it for a while, so I'm really excited for you guys as well. I mean, I think it's just it's a great innovation, and I think you're doing great work for the community. So thank you very much.
Cheers, thanks, Ray. Cheers. Yeah, thanks, BJ. Keep up the good work with your 49th podcast.
Yeah.
Thanks for having us on.
Great.
It's always an absolute pleasure, always, yeah.
Cool.
Just a couple of announcements before we say goodbye. So John, do you know when your talk will be online from Clojure North?
No, they said a month, which was a week ago. So,
in 2-3 weeks, the talk should be out.
Yep.
So look for that one, people who are listening. And Dutch Clojure Days was it was good, and other people said it was good as well. So I'm just trying to say that it was good.
Nice.
And we have all the videos up and running on YouTube. And Heart of Clojure tickets are open right now. So book your spot to go to Heart of Clojure. I know Jext is sponsoring Heart of Clojure, so probably John, you'll be there.
Yeah.
Or somebody from maybe Jeremy, both of you, or Malcolm, or the whole Jext gang.
Yeah, that'll be a hotel or a Jux pad somewhere. That'll be quite fun.
That'll be amazing. So I think I'll show up there as well. So I'll
cool.
So if you the people who are listening, go and check out heartofclojure.eu. I think get your tickets. It's in August. So that's it from us. Thanks again, Jeremy and John, taking your time to explain the meaning of Crux, and from thinking that it's a point of pain to actually it's the crux of something. That's the main idea.
Yeah. Cool.
So
thank you very much.
Thank you.
Thanks, guys.
Goodbye.
Goodbye.
Cheerio.